I have in mind a few projects and I thought I would use collets as tool holders. I found an affordable set with which to experiment with and also got a hex collet block. For what I paid, the quality is great. The collet block would also serve as a guide on building collet chucks. In order to experiment with building a collet chuck, I started by making a square collet block. This is the finished item. It is ground all over and is accurate to 0.02 millimeters. Encouraged by my success, I then proceeded to build a runout adjustable ER collet chuck, also known as set true chucks, for my mill. This is my power hacksaw I built some 20 years ago, cutting through 30 by 30 millimeter steel stock. It sure saved me some elbow grease through the years. Here I am squaring the stock using a fly cutter. Then I grind two of the faces using the surface grinder I built. Two surfaces of the block will be parallel to each other. I shall check this on the granite plate. In order for the other two surfaces to be square to those I just ground, I attach the stock to an angle plate. The surface in contact with the angle plate is ground. I use the DTI to verify it is level, before grinding it. After grinding this surface perpendicular, I ground the opposite surface parallel to it and to dimension. The surfaces are parallel and of equal dimension. The block is now truly square shaped. Here I am centering the block in the 4-jaw chuck. I have attached pieces of flat stock to project the sides of the square. The dial indicator is on center and I fitted an arm 90 degrees to its stem. I then locate the lowest point and mark its position using the graduated chuck backing plate. I then add 180 to this value and find the opposite side in order to adjust the opposite jaw. This saves me time. Having centered the block, I verify that it is not held skewed. It is held properly. The block needs to be turned down to 32 mm for a length of around 20 mm. I fitted my lathe with an automatic carriage stop. It trips the half nut at a set point, making turning to a shoulder very easy. The cutting tool is located where the cut needs to stop. The trip bar is then set against the stop and locked in place. It shall trip the spring-loaded half nut lever at the selected point. The half nut lever has a selector which allows me to switch between normal and automatic mode. Automatic mode is selected. The carriage is wound back and the cut is set. The half nut engagement indicator tells me when to engage the half nut. The trip bar accompanies the fixed stop. You can see it slowly turning the sear holding the spring-loaded half nut lever until it is released, disengaging the auto feed. The stop is finally turned to 32 mm. Now to cut a thread M32 by 1.5 mm. The thread gutter using a spring parting tool I made ages ago. The flexible tool holder allows the cutting tool to be pushed away from the work instead of jamming. I just made a scratch pass to verify that the threading gears were correctly set. The threading tool swings upwards to clear the workpiece. Here I am returning it to the cutting position. Like most hobby lathes, mine did not have a thread dial indicator. So I built one. It has made threading a lot easier. The auto carriage stop also comes in handy when threading, as it is set to trip in the thread gutter. fits nicely. Now I have to make the collet taper. I start by drilling with a split point drill followed by larger drills and finally boring the sides. The auto carriage stop also comes in handy when boring. The collet taper can now be cut. First, the compound is set to 8 degrees using its protractor. A dial indicator is held on center in the tool post. The dial indicator is set perpendicular to the compound. Using trigonometry, to cut an 8-degree taper, a 20 mm movement of the compound would result in a reading of 20 times tan 8 or 2.81 mm. After zeroing the compound and dial indicator, the compound is advanced by 20 mm and the dial indicator should be close to 2.81 mm. If not, the compound angle is adjusted and the process repeated till it does. The taper is then bored. The runout is 0.01 mm, quite good. However, I would like to try grinding the taper to see if the runout can be improved. I am using a die grinder held on center in the tool post. After covering the chuck and ways, I proceed to true the grinding wheel. That bore looks really nice. Grinding didn't seem to make much difference. These collets were very affordable, but the quality was remarkably good. The runout is quite acceptable and is likely due to the collet. Now to check the work. I am using two bearing rollers as parallel so that the nut can clear the surface plate. The first face shall be the reference one and is marked 0. The second shows 0.015 millimeters. The next 0.02 millimeters, and the last again 0.02 millimeters. This is equivalent to the runout seen whilst it was in the lathe. All in all, I am very satisfied.